start with a preliminary test. Wash all the apparatus with water. Test 1. Let us find the nature of the salt. Take a pinch of the salt in a small test tube. Add about 1 to 2 ml of water. Shake well. Has the salt dissolved? The salt has dissolved in water. This shows that the salt is crystalline in nature. Test 2. Observe the color of the salt. The color of the salt is white or colorless. The salt may contain aluminium, barium, strontium, calcium, ammonium, zinc, magnesium or lead radical. B. Let us now perform the dry test for cations. Test 1. Heating in a dry test tube. Take a small quantity of the given salt in a dry test tube and heat it. Observe the changes taking place. What is the color of the residue? There is a white residue at the bottom of the test tube. This shows that the salt may contain lead, aluminium, zinc, calcium, strontium, barium or magnesium as one of the radicals. Test 2. Charcoal cavity test. Make a shallow cavity on the surface of the charcoal. Take a pinch of the salt. Add to it a pinch of solid sodium carbonate and a drop of water. Mix it properly. Fill this salt in the charcoal cavity. Hold this charcoal piece with a pair of tongs. Using a blowpipe, direct the reducing flame on the charcoal cavity to heat the salt in the cavity. Observe the changes taking place. There is a white residue. This indicates the presence of aluminium, barium, strontium, calcium or magnesium as one of the radicals. Test 3. Cobalt nitrate test. Add 2 drops of cobalt nitrate solution to the white residue obtained in charcoal cavity test. Hold the charcoal piece with a pair of tongs. Using a blowpipe, direct the reducing flame on the charcoal cavity to heat the salt in the cavity. Observe the color of the residue. There is a blue residue formed. This indicates the presence of aluminium radical. Test 4. Flame test. First, we shall clean the platinum wire. Dip the platinum wire in concentrated hydrochloric acid. Then heat the wire in a slow oxidizing flame. Now, take a pinch of the given salt. Add a few drops of concentrated hydrochloric acid to moisten the salt. Dip the clean platinum wire in it and hold it in the outer part of the oxidizing flame. Observe the color of the flame. There is no distinct color imparted to the flame. This indicates that copper, barium, calcium, strontium and lead may be absent. Test 5. Borax bead test. This test is performed only if the salt is colored. As the given salt is white in color, we shall not perform this test. Test 5. Test for ammonium radical. Take a pinch of the salt on a piece of filter paper. Add a few drops of dilute sodium hydroxide solution on it. Fold the paper and smell it gently. There is no characteristic smell of ammonia gas. This shows that ammonium radical is absent in the salt. After performing the dry test, we conclude that the probable radicals present in the salt is aluminium. Now, we shall prepare the original solution of the salt to perform the wet test. Take a pinch of the salt in a small beaker. Add about 1½ test tube of water to it. Stir the solution. The compound dissolves completely to form a clear transparent solution. This is called the original solution. Now we shall perform wet tests using this original solution. Basic radicals are classified into 6 groups depending upon their reactions with specific reagents. With these specific reagents, cations form precipitates of their salts with specific colors and solubilities. Test 1. To detect group 1. Take about 3 to 4 drops of the original solution in a clean test tube. Add 3 to 4 drops of dilute hydrochloric acid. Do you observe a white precipitate being formed? There is no white precipitate formed. This shows group 1 is absent. Test 2. To detect group 2. Take about 3 to 4 drops of the original solution in a clean test tube. Add 3 to 4 drops of dilute hydrochloric acid. Warm the solution. Using Kipp's apparatus, pass hydrogen sulfide gas through the solution. Do you observe a colored precipitate formed? There is no colored precipitate formed. This shows that group 2 is absent. Test 3. To detect group 3A. Take about 3 to 4 drops of the original solution in a clean test tube. Add a pinch of solid ammonium chloride. Add concentrated ammonium hydroxide solution till alkaline. Test the solution with red litmus paper. The paper turns blue, indicating that the solution has turned alkaline. What do you observe? There is a white gelatinous precipitate formed. This shows that group 3A is present and the radical present. Now, we shall analyze the original solution for group 3A. Analysis of group 3A. Take few drops of the original solution in a clean test tube. Add a pinch of solid ammonium chloride. Add concentrated ammonium hydroxide solution till alkaline. Check the alkalinity using a red litmus paper. A red litmus paper turns blue under basic conditions. Shake the solution well. There is a white gelatinous precipitate formed. This indicates the presence of aluminium radical. Let us perform the confirmatory test. Take a few drops of the original solution in a clean test tube. Add disodium phosphate in excess. There is a formation of white precipitate. This further confirms the presence of aluminium radical. Now, let us tabulate the result. The given salt contains aluminium as the basic radical.